Okay, so there's two well-known ways to locate points in free space. The easiest way is x comma y comma z, known as the rectangular coordinate system. The second way is something called cylindrical coordinates, where you use r, theta, and z. Really, you should think of cylindrical coordinates as rectangular coordinates, but we've taken the xy component and used what we know about polar coordinates from the 2D world. And since we can move vertically above along any of these polar points located in the xy plane, you end up stacking circles and creating cylinders. So that's called cylindrical coordinates. Today I want to talk to you about something called um, spherical coordinates, which have components rho, which is the distance from the origin out to your location in space. It has a second value theta, which is the theta that you know about from polar coordinates or cylindrical coordinates. It is the rotation away from the positive x-axis that you've moved. And then this third component is called phi, which is your angle down from the positive z-axis. So sometimes that's called the azimuth, directly north. And we're saying what angle down from north are we rotating. You should keep in mind some restrictions. So rho is infinite, it could be as big as you want. Theta is always bounded between 2 pi and 0. And then phi is bounded between 0 and pi. And if you play around with that, you'll realize you can locate every point in space this way. Let rho be anything in the real numbers. That's the notation for all real numbers, and you can get to any spot in space. It's worth just trying different values of rho, theta, and phi in those domains, and you'll see you can reach everywhere you want to go. One thing you'd want to do is you'd want to convert between rectangular coordinates and spherical coordinates. So how would you do that? All right, so I guess we can pick whichever component we want to go for first. Let's try and look for x and y first. So to look for x and y first, the distance x is along here, this axis. The distance y is here. And if I look, I can see this red bright triangle lying in the xy plane. Problem is I don't know what r is, so I need a little bit of work there. But here's a fun thing you learned about years ago, probably in 7th grade, something called two parallel lines cut by a transversal. So you can see that the line rho here, which I'm bolding right now, is the transversal for the two pink dotted lines. And therefore, this angle up here is also phi, because it's alternate interior with this phi over here. So that's sort of nice. And since we know the length of rho, we can solve for r. So if we look at r, we see its opposite angle, phi. So I'm going to say that the sine of phi equals opposite r over hypotenuse rho. And then if we solve for r, we get rho sine phi is equal to r. So I'm going to put a little rho sine phi here. And then if we look at that red triangle that's lying in the xy plane, we can do a lot with it. We can do little trig ratios. So for example, we can say that the cosine of theta equals the adjacent x over the hypotenuse rho sine phi. And if we solve that for x, we end up getting that x equals rho sine phi cosine theta. We could do a similar thing if we consider the sine of theta. Sine of theta would be opposite y over hypotenuse rho sine phi. And that would tell you that y is equal to rho sine phi sine of theta. So that's good. So now we have x and y. We need to get z. It's going to be easier because to get z, we can just So the triangle I'm thinking of, maybe I'll try to use the colored yellow. See how that works. So you can see this yellow right triangle there. We want Z, which is this vertical side of that right triangle. And so if we were to think about angle phi up here, then we could set up the following ratio. We could say that the cosine of phi equals adjacent over hypotenuse, which would be Z over rho. So let's go write that down. Cosine phi equals adjacent Z over hypotenuse rho. So that would tell you that Z is equal to rho cosine phi. So now you have this nice set of relationships between x, y, and z and rho, theta, and phi.